You're driving beside a massive truck loaded with concrete when you notice something strange. The truck's heaviest wheels hover just inches above the road. It looks like a mechanical glitch or a costly mistake. But there's a high-stakes reason these tires miss the pavement, one that protects roads, saves money, and keeps haulers legal. The logic behind floating truck tires will change how you see every highway ahead. Roads may look solid, but beneath the surface, they're surprisingly fragile. A loaded truck presses down with thousands of pounds on each tire, focusing all that weight onto patches of rubber no bigger than a sheet of paper. The real danger isn't just how much a truck weighs, but how that weight is divided among its axles. Engineers discovered this in the late 1950s during the AASHO Road Test. They found that pavement damage doesn't rise steadily as loads increase. It explodes. Doubling the weight on a single axle doesn't just double the harm, it can multiply it by 16. This is known as the fourth power law. When a truck's axle load jumps from 10,000 to 20,000 pounds, the stretch of road beneath it suffers damage equal to thousands of cars passing by. That's why a single overloaded axle can trigger cracks, potholes, or even deep ruts in a matter of weeks. The pressure from each tire pushes into the pavement, flexing it over and over until the material gives way. Even concrete slabs, which seem indestructible, can fracture at the corners from a single heavy pass. These risks set strict legal limits on how much weight each axle can carry. If a truck needs to haul more, it must spread that weight over additional axles, lowering the pressure on each one. Without this adjustment, highways would crumble far faster than they already do. On the side of a heavy truck, a small switch sits within easy reach of the driver. When the load demands it, this switch activates an air suspension system that brings the lift axle into play. Air flows from the truck's compressor into large rubber airbags mounted above the axle. As pressure builds, typically between 90 and 120 pounds per square inch, the bags inflate and push the axle downward. The tires lower until they meet the pavement, sharing the load with the other axles. This adjustment isn't just mechanical, it's a direct response to legal requirements. By spreading tens of thousands of pounds over more axles, the truck instantly complies with strict weight per axle laws. If a scale check is ahead or a load shifts during transport, the driver can deploy the lift axle in seconds, often while still moving. Height control valves ensure the axle settles at the correct ride height, keeping the truck level and stable. Once the job is done or the cargo is unloaded, the process reverses. The driver vents air from the bags, the axle rises, and the extra tires hover above the road again. This system lets a single vehicle adapt to a wide range of weights and conditions, all with a simple adjustment from the cab. Every mile a tire rolls costs money, and for trucks, those costs add up quickly. Each tire that touches the ground creates rolling resistance, a force that fights against the engine and burns extra fuel. On an empty or lightly loaded run, keeping all axles down can cut fuel efficiency by 5 to 10% according to industry studies. That's thousands of dollars lost each year for a single truck. Tire wear is another hidden expense. When unneeded tires roll along the pavement, they wear out faster, sometimes losing 20 to 50% of their expected life. For a fleet, that means replacing dozens of tires sooner than necessary. There is also the matter of tolls. Many highways and turnpikes charge trucks based on the number of axles touching the road. By lifting an axle, a truck can drop to a lower toll class, saving 10 to 30% on fees in regions like Ohio and New Jersey. These savings go straight to the operator's bottom line, making the simple act of lifting an axle a key part of running an efficient business. Turning a fully loaded truck through a tight intersection is more complicated than it looks. When all the axles are down, the rear tires can't follow the exact path of the front wheels. Instead, they're forced to slide sideways across the pavement. This sideways movement is called tire scrubbing. As the truck pivots, the fixed axles drag their tires against the road, building up heat and friction at each contact patch. Over time, this friction wears down the rubber and puts extra stress on the suspension. In some cases, it even leaves black marks on the asphalt. For the driver, scrubbing means heavier steering and a higher risk of damaging expensive parts. By lifting one axle, the truck shortens its wheelbase and reduces the number of tires fighting the turn. The result is a smoother, tighter arc that's easier to control. The truck moves through loading docks and city streets with less effort, and the tires last longer. This simple adjustment can make the difference between a clean turn and a costly repair. Every raised axle is a real-time adjustment to rising costs, stricter regulations, and aging roads. Even small engineering details shape how freight moves and how our infrastructure survives. Thanks for watching.